Hey guys, Mr. Backer here. In this video, we're going to look at circular arc length. Now, as we're talking about all of these different ideas with angles, we typically use Greek letters to represent angles, and the one that we're going to see used most often looks like a zero with a line through it. That's the Greek letter theta. So anytime you see theta in an example, or in an equation, or in a statement, that just means that we're dealing with some angle. So as we're taking a look at finding the arc length of a circle, what we're going to be dealing with is some theta, which is a central angle, and we have to make sure that we're measuring that theta angle in radians. When that theta angle intercepts our circle, it creates a small arc, which we're going to call S. And in order to find the length of S, what we can do is we can take the radius of our circle times the radian measure of our angle theta. Now, we can also calculate arc length using degrees, but the formula is not quite as simple as using radians. So if we think about that radian formula where we've got S equals R times theta, to take this theta and convert it into radians, we would have to multiply it by pi over 180 degrees. So then we get a new formula that says the arc length is the radius times the angle theta times pi all over 180. So we're going to take a look at this example where we want to find the perimeter of a slice of large pizza with a 7-inch radius, and our pizza has been cut into 6 equal pieces. So we're going to focus on just one of our slices. Now, they do tell us that our pizza has a radius of 7 inches, so this length right here is 7 inches, and this length across the bottom is also 7 inches. They also tell us that our pizza has been cut into 6 equal pieces. Now, we know that a full circle is 360 degrees, but if we cut that into 6 equal slices, then that's going to give us a 60-degree central angle here in the middle. Now, if we want to find the perimeter, we already know that these radius lengths are going to be 7 inches each, but we need to find the length of this arced portion of the crust. So we're going to have to use our arc length formula. And because we're dealing with degrees, then we're going to use that degree formula. So in our formula, we know that the radius is 7 inches. We know that our angle theta is 60 degrees. We have to multiply that by pi and then divide by 180. Now, when we type all of this into our calculator, we should get about 7.3 inches. So now if we add up that total distance around the outside of this slice, we're going to end up getting about 21.3 inches around the outside of this slice. So we're going to take a look at an example where we are designing a track, and we want the running lanes on the track to be 1 meter wide. The inner radius of the first lane is 33 meters, and the inner radius of the second lane is 34 meters. And we want to figure out how much longer lane 2 is than lane 1. So we're going to use our arc length formula. Now, as we're taking a look at this example, we're going to use radians, and because we're looking at half of a circle is 180 degrees, but that's also pi radians. So we're going to use a theta measure of pi. So if I want to look at the inner radius of lane 1, then in order to find that arc length, I would take the 33 meter radius times pi. But if I wanted to take a look at the arc length of the second lane, then I would take the 34 meter radius times pi. Now, if we want to find the difference between these, then what I'm going to do is take the 34 pi and subtract away the 33 pi. So it ends up being about pi meters longer, which we know pi is 3.14. So we can say that lane 2 is 3.14 meters longer than lane 1. That's going to be it for this video. Thanks for watching.